All right, I'm going to be going over lesson 17.3, solving systems of linear equations, the elimination method. So for this, you need to be able to, at the end of the lesson, I can solve a system of equations by elimination. I can explain why the x-coordinate of an intersection is the solution to f of x equals g of x. And then for this one, the foldable, we were going to have, or no, this one is the foldable. So for this foldable, you will do that solving systems of equations foldable on the yellow paper. So that one, you will do part 3 after this lesson. And I put the entire video link on the course calendar. So if you already did parts 1 and 2 with me in class, then just fast forward to part 3. So vocabulary: system of linear equations, solution of a system, substitution, and elimination. Task 1, discovering the elimination method. Elimination is another algebraic method that may be used to solve a system of equations. Two equations can be combined to yield a third equation that is also true. The elimination method creates terms that add to 0. So you may see this in your vocabulary packets. Remember, those bold terms are important to highlight. Follow the steps below to solve the system using the elimination method. So here are the steps on the left-hand side. Step 1, we need to eliminate a variable. Let's eliminate y, since there's a positive y and a negative y. So remember, when we eliminate, we need one positive and one negative. So I see that I have negative 2y and I have positive 5y. And then I also want to make sure that my terms line up. So just to double check, I have my x terms first, my y terms second, and my constants third. All right, so now we want to multiply our terms to get the same number. So if I have negative 2y and 5y, I know a common factor of that would be 10. So I want to get this to be negative 10y and positive 10y, so they eliminate each other or cancel each other out. So the reason it's written twice is so that we can multiply both sides. So negative 2 times 5 will give me negative 10y, and 2 times 5y will give me positive 10y. So now I'm going to multiply those, and I have to multiply everything in that equation to make it equivalent. So 5 times 3x is 15x minus 10y, and then 5 times negative 21 is negative 105. Then I have to multiply everything in the second equation by 2. 2 times 2x is 4x, 2 times 5y is plus 10y, 2 times 5 equals 10. All right, these are equivalent equations. Now I can add them together. So let's look over here, multiply the first equation by 5 and the second equation by 2. We did that. Then we're going to add the two equations. This should eliminate the y. So I'm going to add these together. 15x plus 4x equals 19x. Negative 10y plus 10y cancels out. That's 0. Negative 105 plus 10 is negative 95. So technically I could write plus 0y since it's written down here. Now I plug in my numbers. I have 19x plus 0y equals negative 95. Now I solve the new equation for x. So 19x plus 0y equals negative 95. I'm going to divide both sides by 19. X equals negative 5. Then I'm going to do step 4, find y, by substituting the value of x into one of the original equations. So I go back up here. I'm going to choose my 3x minus 2y equals negative 21. But instead of x, I'm going to plug in negative 5. So 3 times negative 5 minus 2y equals negative 21. Now you just solve that. 3 times negative 5 is negative 15. Minus 2y equals negative 21. All right, now we solve for y. So again, do your inverse operations. First, look at the side that we're solving for. Look at y. First, do the opposite if it's adding or subtracting. So if I have negative 15, I want to add 15 to both sides. Then I get negative 2y equals negative 6. Then I'm going to rewrite it over here since I'm running out of space. Divide by negative 2, y equals 3. So y equals 3. And then step 5, check your solution by substituting in the second equation. So going back to the second equation up here, 2x plus 5y equals 5, now I'm going to plug in both my x equals negative 5 and my y equals 3, just to double check that those are correct. So 2 times negative 5 plus 5 times 3 equals 5. 2 times negative 5 is negative 10, plus 5 times 3 is 15. Negative 10 plus 15 does equal 5, so that checks out. So that is a solution. So again, always write your solution as an ordered pair. Negative 5, comma 3. So if we were to graph these two equations, this would be the intersection point. And also if I plug in negative 5 for x and 3 for y in both equations, it'll solve and equal the same on both sides. All right, now task 2, foldable, complete part 3 of the solving systems of equations foldable. Again, I have a video posted on the course calendar. The video goes through all 3 parts in case you were absent for any of them. So if you already did part 1 and 2 with me in class, then you can fast forward and go to part 3. All right, now that you've done the foldable, now I want you to use your foldable to help you work through these problems on task 3, solving by elimination. So again, you want to pause this video and solve it on your own first, because you want to make sure you know how to do it independently and practice. If you just keep playing this through and just copy down what I'm doing, you're not going to learn it as well. So please pause the video right now, try it on your own for this first example. Then you can come back, check your work with my video. So for each practice problem, I want you to pause it, try it on your own first, and then come back and check your work. Even if you're not sure if you're doing it right, we learn from our mistakes, so I want you to try it, and hopefully as you keep doing it more and more, you'll get it more. All right, so pause it now. All right, so you should have solved this problem on your own, so let's check your work. So we have x minus 5y equals 2, x plus y equals 8. So going back to the foldable, use the solve by elimination section. So remember, we want to line up our equations so our variables match up for step 1. So our variables do match up. We have our x terms first, our y terms, and then our constant terms. Then step 2, multiply one or both equations by a constant so one variable cancels. All right, well, make it easy on yourself. I noticed that my x terms, they're both 1x. So I just need to make one of those negative. And so I am going to choose and it doesn't matter which one, but I'm just going to choose the second equation, and I'm going to multiply everything by negative 1. So then I'm going to rewrite them on the right. X minus 5y equals 2. And now I'm going to multiply, so negative 1 times x is negative x. Negative 1 times y is negative y. Negative 1 times 8 is negative 8. All right, then going back to your foldable, step 3, add equations together to eliminate one variable. So now I need to add these together. X plus negative x cancels out, so I don't need to write anything. Negative 5y plus negative y is negative 6y. And 2 plus negative 8 is negative 6. So now I have negative 6y equals negative 6. All right, now I solve for y, divide by negative 6 both sides. y equals 1. All right, we're partway there. We have our y value. Now we need to figure out our x value. Going back to the foldable, so we solved the new equation. Now we need to substitute the value for the variable into either equation from step 2 and solve. So going back to my original equations, I can pick either one of these. So I think the second one looks easier to solve. So x plus y equals 8. But if I know y equals 1, I'm going to substitute that for y. So x plus 1 equals 8. Solve it, subtract 1 from both sides. That cancels out. X equals 7. All right, so right now I see my solution is 7, 1. But again, always check your work. Go back to the equations, plug them in to make sure they work. So if it's x minus 5y equals 2, I'm going to plug in 7 for x and 1 for y. Solve it. Negative 5 times 1 is negative 5. 7 minus 5 is 2. 2 does equal 2, so that checks out. And then also check the other equation, x plus y equals 8. So x is 7 plus y 1. 7 plus 1 does equal 8. They both check out. So that means my solution is correct. So my solution is the ordered pair 7, 1. So if we were to graph these two lines, they would intersect at 7, 1. All right, again, pause the video and try this one on your own first, and then when you're finished, come back. Hello, this is Catherine. Hey. Hey, can I call you back? I'm making a video right now. Okay, thank you. Sorry about that. All right, x plus 2y equals 8, 3x minus 4y equals 4. So you should have paused the video. If you haven't yet, pause the video and do it, and then come back. All right, step 1, line up your equations so your variables match up. So we have our x values, our y values, our constants, they are lined up. Step 2, multiply one or both equations by a constant, so one variable cancels. So again, first look to see if you have a positive and a negative of the same term. I see that my 2y is positive and my negative 4y, that's negative. So my y terms, one's positive and one is negative. So I'm going to go with those terms. So I need to cancel it out. I know that 2 times 2 is 4. And if that's positive 4y and this is negative 4y, those will cancel out. So I'm going to multiply this first equation by 2. So 2 times x is 2x. 2 times 2y is 4y, and 2 times 8 is 16. I'm not going to change my other equation, so I'm going to rewrite that the same. All right, then we go back to the foldable. Step 3, add equations together to eliminate one variable. So I'm going to add these together. 2x plus 3x is 5x. 4y minus 4y cancels out, so I don't need to write that. 16 plus 4 equals 20. All right, then step 4, solve the new equation. So 5x equals 20. Divide both sides by 5. X equals 4. Step 5, substitute the value for the variable into either equation from step 2. So I go back to my original equations. I feel like this first equation will be easier to solve. So x plus 2y equals 8. But I know x equals 4, so 4 plus 2y equals 8. Again, inverse operations, first look at what you're adding or subtracting to the side with the variables. So 4 plus, so I'm going to do minus 4 to both sides. 2y equals 4. And then it's 2 times y, so the inverse would be divide by 2. Y equals 2. Always check your work. So let's go back to those original equations and substitute x equals 4, y equals 2. So if I have x plus 2y equals 8, I'm going to put 4 plus 2 times 2 equals 8. 2 times 2 is 4. 4 plus 4 is 8. So 8 equals 8. That checks out. Then I go to my second equation, 3 times 4 minus 4 times 2 equals 4. 3 times 4 is 12. Negative 4 times 2 is negative 8. 12 minus 8 equals 4. 4 equals 4. They check out. So my solution for these two equations is the ordered pair 4, 2. They will intersect when graphed. All right. Last one like this. Again, pause the video right now and try it yourself. Okay, now you should have done it yourself, so now let's go over it. So again, step 1, line up your equations so the variables match up. My x terms line up, my y terms line up, and my constants. Step 2, multiply one or both equations by a constant so one variable cancels. So let's look. I see that my y terms, one's positive, one's negative. I'm going to go with those. I have 5 and negative 3, so I know a common factor would be 15. So I'm going to multiply the first equation by 3. 3 times 7x is 21x. 3 times 5y is 15y. And 3 times 9 is 27. Then I'm going to multiply my second equation by 5 because negative 3 times 5 is negative 15. 5 times 4x is 20x. 5 times negative 3y is minus 15y. 5 times 11 is 55. All right, step 3, add equations together to eliminate one variable. Add these together. 21x plus 20x is 41x. My y terms cancel out. 27 plus 55 is 82. Then step 4, solve new equation. So if I have 41x equals 82, I divide 41 by both sides. 82 divided by 41 equals 2. X equals 2. Step 5, substitute the value for one variable into either equation from step 2. So I have my original equations up here. I'm going to solve the first one. It's all positives. I feel like that one will just be easier, but again, it doesn't matter which one you choose. So 7 times 2 plus 5y equals 9. 7 times 2 is 14. Plus 5y equals 9. Now I want to subtract 14 from both sides. That cancels out. 5y equals negative 5. Divide both sides by 5. Y equals negative 1. Alright, before we decide this is our solution, we always want to check our work, go back and substitute them into the original equations. So I'm going to do the first one. So 7x would be 7 times 2 plus 5y times negative 1. 7 times 2 is 14 plus negative 5 equals 9. 14 plus negative 5, 9 equals 9. Checks out. All right, try it in the other equation. 4 times 2 minus 3 times negative 1 equals 11. 4 times 2 is 8. Negative 3 times negative 1 is positive 3. 8 plus 3 does equal 11. So this is our correct solution. Write it as an ordered pair to negative 1. All right, then you also will see word problems in real-world contexts given. So let's solve this first one together, and then you're going to try the other ones on your own. So write and solve the following systems by any method. You may use a separate sheet of graph paper if you choose the graphing method. So again, you might not want to use my method. You can go and use any method. So I'm just going to do the first one, and then you can use the key that I'm going to post on the course calendar to check your answers for 2 through 4, because you might use a different method than me, and you can at least just check your work based on what method you decided to use. So I'm just going to do number 1 in this video, and the rest you'll have to do on your own and check using the key. All right, so Minnie has 9 coins in her pocket. All of the coins are nickels or dimes and are worth a total of 55 cents. How many of each type of coin does Minnie have? So first we want to label our variables. So this one, I'm not sure what method I'm going to use, but if I go back to solve by substitution, it says define your variables for this first step. So let's just define our variables. So I know that there's coins, I have nickels or dimes. So I'm going to make x nickels and y is going to represent dimes. And then just to review, nickels are worth 5 cents and dimes are worth 10 cents. All right, then we are going to look at step 2. Write your equations based on what you know. So I know that she has 9 total coins in her pocket, so I'm going to write an equation for the number of coins. So she has x nickels plus y dimes, and that equals 9 total. Then I want a second equation, and I'm going to go with how much everything is worth. So I know that dimes are 5 cents, so that's 0.05x. I know that x is my nickels. Nickels are 5 cents, plus 0.10 y, because dimes are 10 cents, and she has a total of 55 cents, so 0.55. Okay, these are my two systems, and we usually put those brackets around them. All right, so I'm just going to solve by substitution because I see that up here I can easily solve for one of my variables, so I'm just going to continue using substitution, but again, you can use any method. So step 3, solve one equation for a variable. It doesn't matter if we choose x or y, so I'm just going to solve it for y. So if I have x plus y equals 9, and I'm solving for y, I want to subtract x from both sides. So then y equals negative x plus 9. All right, so I solved for my y. I have y by itself. Now substitute the expression for the variable in the other equation and solve. So now I'm going back to my other equation, and I'm going to substitute negative x plus 9 for y. So I'm going to put 0.05x plus 0.10, but instead of y, I'm putting negative x plus 9 equals 0.55. Now I have to solve this. Notice how now I just have x. You can only have one variable when you're solving for it. So now I distribute 0.05x plus negative 0.10x, because that's a negative x, plus 0.90 equals 0.55. Combine your like terms, 0.05x plus negative 0.10x, that's going to be negative 0.05x plus 0.90, oops, I messed up there, equals 0.55. Alright, then add or subtract your constants. So if it's plus 0.90, I'm going to subtract 0.90. That'll cancel out. I'm left with 0. Negative 0.05x equals 55 hundredths. Divide both sides by negative 0.05. X equals, oh, I totally messed this up. Going back here, if I subtracted negative 0.90, I did minus, I need to do it to the other side, so I totally missed that, so I'm going to go back and fix this. So if I have 0.55 minus 0.90, I'm going to get negative 0.35. When I divide that by negative 0.05, I get x equals 7. This one's kind of tedious. All right, then I go back to the foldable, substitute the value for the variable into either equation from step 2 and solve. So x equals 7. I'm going to go back to my easier one, x plus y equals 9. So 7 plus y equals 9. Subtract 7 from both sides, y equals 2. Before I decide this is my solution, check my work. So I'm going to go back to x plus y, 7 plus y, 7 plus 2 equals 9, 9 equals 9. And then you can also check the second one. I'm running out of space, so I want you to check it, but to get that practice. But we know that our solution is 7, 2 as an ordered pair. And then if you are asked to interpret your solution for step 6, that means that she could have a combination of 7 nickels and 2 dimes in her pocket to equal 55 cents. All right, again, you need to do 2 through 4 on your own and use any method. So we've gone over graphing, substitution, and elimination. There is graph paper on the counter on that second shelf under the lined paper. So you may use some graph paper if you want to do graphing, and then you can check the key. Now, again, I might have used a different method than you, but you should still get the same answer.